Hello everyone, welcome to my channel. I'm Caleb, and I'm going to show you how to delete your STM32. Wait, no, hang on, that's not right. Sorry. I meant upload the USB bootloader to the STM32. Just a quick note, if you want to skip this short introduction and get right into the meat and potatoes, go to this timestamp. I would recommend watching the entire video because there is useful information interspersed throughout, but you should be able to get it up and running faster if you skip ahead. And now, time for the introduction. I'm just like any other hobbyist, which means I love Arduinos. However, the Arduino Nano clones weren't cutting it for me anymore. My search for a better board led to the cheap and feature-rich STM32. When I first bought one of these boards, I tried to plug it into my computer. However, the COM port that normally appears with Arduinos never showed up. After some research, I found out that these STM32 boards don't ship with a USB bootloader. Instead, they ship with a serial bootloader. To upload code, you need one of these knockoff FTDI breakout boards/serial adapters. If you've ever worked with a Chinese clone of the Pro Mini, you should have one of these lying around. If not, they only cost a few bucks, and if you need to pick one up, the links are, as always, in the description down below. While the lack of USB support may seem like a hindrance, it can actually be a benefit. The USB bootloader uses 20K of the 64 kilobytes available. However, it is severely inconvenient to use the serial adapter, and I've never had a project surpass the 18MB 328 32K anyways. The reason I am making this video is that I wasn't able to easily find information on how to add USB bootloader support. I've compiled my findings, and hopefully you will find this very easy. Now fasten your seatbelts, and let's get started. First, grab your serial adapter, knockoff or otherwise, and set it to 3.3 volts. If you don't change the voltage, you will definitely release the magic smoke. Unfortunately, they don't sell magic smoke refilling tools anymore. You will have effectively destroyed your precious board. Grab your STM32 and the adapter board and connect the ground lines of the two boards together. If you want to, you can connect the 3.3 volt rail of the boards together to avoid two simultaneous USB cords. However, double check with a multimeter that the VCC of the adapter board is outputting 3.3 volts. The safer option is to leave it unconnected and just use two USB cords. The next step is to connect the TX of the adapter board to A10 of the STM32 and RX to A9. And finally, move the boot 0 jumper to the 1 position and connect the USB, or USBs, to your computer. If you want to just upload a simple sketch, now is the time to try it. I would recommend the standard Blink program as a good test. However, you may need to replace LED built-in with your LED's pin ID. In my case, the LED's pin was PC13. To send the code, make sure that you install the STM32 F1XX boards package and select generic STM32 F103C series and upload method serial in the tools menu. Finally, click the upload button. The LED should start blinking, obviously, and if this isn't the case, now is the time to check your wiring, the boot 0 jumper, and COM ports. Moving on, go to the links in the description and download the Flasher Loader demo from the ST website. We also need to tell the computer how to interact with the STM32. Download the drivers from the link in the description. To install these drivers, run the install-drivers.bat and follow the instructions provided. If the device ever starts acting up, which can happen due to Windows updates or anything similar, reinstall these drivers and unplug/replug the STM32. An example of one of these issues is the uploader getting stuck on searching for DFU device 1EAF:003 and then erroring. Only one more download to go. Navigate to the Binaries link and download the correct version of the bootloader for your board. You can tell which version is correct by checking which pin is connected to the LED. My board has the pin on PC13, so I chose the generic boot20 PC13.bin file. And now it's time for the bootloader install. Make sure the boot 0 jumper on the STM32 is set to 1. Make sure that your serial adapter is connected, and run stmflashlowderdemo.exe. Note, I had to navigate to my program files x86 and found it in the ST Microelectronics directory. Select the correct port and click Next. If the program freezes or doesn't work immediately, check that your serial adapter is connected correctly and that boot 0 is set correctly. Unplug and replug your boards and try again. You should now see a green stoplight that says target is readable. This page also tells you the flash size. Click Next. This screen shows all of the memory pages and their read-write protection status. They should all be unlocked. Click Next. Select the Download to Device radio button and click the 3 dots next to the Download from File text box. Navigate to the bin file that you downloaded in my case generic boot20pc13.bin, and select it. You may have to change the file type to .bin in the navigation menu on the bottom right. You shouldn't have to change anything else on this screen once this file has been selected. Hit Next and wait for the flash to be updated. Close out of the program. Before you remove the power from the board by removing the USB and serial adapter, switch the boot 0 back to 0. If you don't do this step, you will have to go back through and re-upload the .bin with Flash Loader Demonstrator again. You should be done. If it all went correctly, you can now unplug your serial adapter from the board and plug in a micro USB. Open up the standard Arduino Blink program. Go to the tools and change your build settings to the following: board, generic STM32 F103C series, and upload method STM32 Arduino bootloader. Everything else should already be set correctly. Select the right serial port, mine was listed as Maple Mini COM4, and click upload. If everything was completed correctly, you should see the built-in LED start blinking. If the board throws an error and complains about the DFU device not being detected or something, install the drivers mentioned above again and restart the program and your computer. If that doesn't help, it could be an issue with your resistor. The board should have a value of 1.5K for R10, but instead most have a 10K resistor. For most computers and boards, this is not an issue. However, this can cause issues in the long run. I've never had a problem with it, but that doesn't stop you from having a problem with it. There is a potential workaround listed in a few seconds that may help if it happens to you. Having successfully completed your STM32 bootloader install, here are a few other getting started tips. You may want to resolder the micro USB connections because they are usually poorly soldered from the factory. Great Scott did a great video on the STM32 and I would highly recommend it. Click the card that should have just appeared somewhere to check his video out. We used boot 0 for uploading the firmware to the STM32. However, we never touched boot 1. Now with the USB bootloader, boot 1 places the board into perpetual DFU mode. This allows us to upload code even if the Arduino IDE can't place the board into DFU mode. This could potentially be a workaround if your R10 is causing issues. Thanks everyone for watching this video. I hope this was helpful and I look forward to seeing your success stories in the comments. Hopefully this simplified and/or conglomerated the information out there into something useful. I'm thinking about creating a mini-series with the STM32, comparing it to other Arduinos and doing some stress testing. Tell me if you think that'd be something exciting to watch. That's all for now. I'll see you guys next time. Thanks, and bye-bye.